And all joining with us today. This is your host, Aditi Nanda, welcoming you to today's special webinar. We have been joined by the very acclaimed and multi-talented Dr. Hardik Patel. Sir, I welcome you on the behalf of the entire team of the World Implant Expo to this webinar.
Thank you.
Ladies and gentlemen, Dr. Patel completed his BDS from Amravati University, India in the year 1998, post which he went on to pursue his DDS from the New York University, USA. He currently runs a private practice in New Jersey and has been active in spreading smiles since the year 2005. He's a diplomat, American Board of Oral Implantology, fellow Implant Dentistry, University of Nevada, Las Vegas, fellow Academy of General Dentistry. He's a director, AAID course, AAID master course in oral implantology, California Implant Institute. He's a certified IV sedation provider. He's the owner of Digital Dental Laboratory. He's also the founder of 3D Implant Institute, USA, and co-founder, Advanced Implant and Dental Education. He's the executive board member at American Academy of Clear Aligners, USA. He's a consultant and key opinion leader for various technology companies. It is rightfully said, whatever the human mind can conceive, it can achieve. And I think Dr. Patel fits quite well into it. So the participants and myself are eagerly looking forward to dive into the world of 3D printing with you. Thank you once again for joining us.
Thank you for the invitation. Are we ready to share?
Yes, please, sir.
Share my screen. Just let me know you guys can see it. Can we see it?
In a minute, sir. It's uploading. Yes, we can see.
The first one. Okay, let me know when it's uploaded.
Yes, sir, it's uploaded.
Okay, well, I appreciate Dr. Nanda for opportunity to speak, as well as the organizers of World Implant Expo. I hope everybody joins. It's going to be a great education event. That being said, I'm going to start with 3D printing in dentistry. And I've been printing since 2015. I have about 14 printers now in my lab, and we try lots of different things, and I've seen this thing change. So I'm going to share certain things with you, and hopefully it's going to be enjoyable for you guys. So impossibilities are merely things which we have not yet learned. So learning never stops. I know 3D printing is probably brand new in a lot of the parts of the world, and the horizons are just changing every day. Every day there's something new, and whether you like it or not, 3D printing is going to be in your office sooner than later. So let's just go over with the basic parts of 3D printer, right? So you have a resin tray, which is a reservoir for your resin. It collects, it saves the resin for printing. You have a platform on which the print was going to print. It's going to go up and down, and it's going to print. Your print's going to be attached to the platform. There's a motor that moves the platform up and down, and then there's a source. It could be just like a television set, right? It has an LCD, DLP, CDLP. The whole purpose of a source is to project an image of three-dimensional image of what you're trying to print. How expensive is it? You can get something really, really cheap, $300, or you can spend $60, $80, $100,000. They all work depending on the things that you need to do and how fast you need to do things. Photon Sonic Mini is a really good printer. It's $300, and it's available everywhere in the world. That's what I would suggest you to start. And then once you print the material or anything, let's say you're printing a cast, it's basically a liquid that's cured on the platform. So there's going to be extra resin and everything in there. So that needs to be washed off before it becomes usable. So after the print, you have a washing unit. that's going to remove all the excess. You have a curing unit that's going to cure the rest of the resin that's outside. Right now, I mean, this slide is about a year old, but things are already changed. So this best dry washing unit, it's no longer applicable. Just take it with a grain of salt. Every day there is new stuff. So you don't have to use an automated processing unit. You can use a regular spray bottle with alcohol in it, and that will work just the way fine. Auto Flash is one of the best units in that right now, but there's more companies that's making more affordable. You can have a curing unit as little as $60 now from Amazon. So what do you need in terms of 3D printing? How can you get started with it? So you need a source of the image, a 3D file. Typically, it's from intraoral scanners. If you don't have an intraoral scanner, you can send it to a lab, which can scan your model and convert that into a 3D. You need a 3D printer, and then you need to have resins to print, whatever you need to print, a mouth guard or temporary crowns or smile design with the temporary veneers. Possibilities are endless. You can do so much with it. What printer do you buy for your practice? There's various. So if you start from, again, this slide is about a year old, so all this lineup has changed completely now. But the basics still remain the same. You have your Envision Tech, Sprint Tray Pro. Those are the main common ones nowadays. Then you have a Form Labs, which is an older technology. I want to start with the basic question first. What are you going to use 3D printer in the office for? Are you going to just print models? If you're just going to print models, any cheap printer will do, because models are less sensitive to dimensional changes. Its current 3D printers are pretty accurate for models. If you're gonna print veneers or crowns, then you need a higher resolution printer, just like you have television sets with 4K or 1080p or 720p. The details that come out on the prints is going to change with the resolution. So higher the resolution, faster it's going to print, but the quality of the print is going to be less than ideal. What printer technology will be best for you? Laser works really good, but it's slow. Versus the current version is DLP. Those are really fast. You can print a model in laser. It will take about 4 hours, but versus DLP, it will take about 20 minutes, 25 minutes. There's a new printer that is just out last week. It's 10 minutes for model to be printed. How fast does it need to be? Can you put it overnight and then come back in the morning, or you need to have something done within 15, 20, 30 minutes? How big of the room is going to take? Some printers are as big as like a desk, that tall, big. Some are little tiny, little boxes. So it depends on what you need or how much room you have. Can your staff or can your team learn how to do this? As a dentist, it's advisable for you to work and transfer this to a third party who can process these things for you. And then ultimately, what is going to be the return on investment? So if you buy a $300 printer, how much do you anticipate to make out of that money? So resolutions, X, Y, Z. Y and X is the horizontal axis, and the Z is the vertical axis. XY resolution is the actual resolution of the printer. The Z axis is basically how tall each layer is going to be. So when the 3D prints are happening, it prints layer by layer. So it's essentially, you're building stacking of the paper one by one, and then you got a whole ream of paper. So the 3D printing works the same way. It starts with the low, first layer, then the second layer, the third layer, the fourth layer, and more resolution on the Z-axis means faster it will print. So ideal is about 100 microns, but if you want a very fine detail, then you need to have about 25 microns. Surgical guides, you need 25 to 50 microns. Models, 170 microns, 200 microns is good enough. These are some of the technologies. As you go from left to the right, it's older to the newer technology. And also the speed will change from left to right. Material jetting and FDM is really, really fast, and most of the big industrial companies are using Stratasys um, and carbon and stuff like that. So a lot of your Nike shoes, Adidas shoes are 3D printed. The soles are 3D printed. Airplane parts, panels are 3D printed. Car parts are 3D printed. So those are the really big machines, and they're really fast. In the dental office, you're going to be using DLP and CDLP most of the time. Some labs also use FDM and material jetting. So, like I said, the source laser is a source. It's just going to project underneath the tray. So that's the platform. Can you guys see my arrow? So that's the platform. That's the resin tray. This is a mirror, and that's the projector source. It's going to beam off onto the bottom of the tray, and that's how it's going to print. With the DLP, the source is right underneath the tray. So it's, it's like you watching a movie with a projector. And then MSLA just have multiple sources, and that's why they work faster, because every projector is going to project a little piece of the 3D part. So it's a lot faster. This is how SLA prints. It's little by little by little. And that's why it takes longer. With the DLP, the whole layer is printed at one side, one go. So if you have 10 models, it will take the same time versus 5 models or 2 models. It doesn't matter how many you're printing, it's going to take the same amount of time. Versus SLA, if you're going to print 10 models, it will multiply that time by model. So if you print 1 model, it'll take 4 hours. If you print 10 models, it will take you 40 hours. As of now, and this is changing again, SprintRay and EnvisionTech are the two bigger companies in the dental industry, at least in the US. SprintRay is a little bit ahead now because EnvisionTech was bought out by an industrial company, so they're limiting in development now. SprintRay is solely a dental-focused company, and they are currently one of the best resin manufacturers at this point. So this is how it prints. The platform goes up and down. On the bottom, if you see the blue light, is the source of the projection. And every time it prints, it goes up and down. Versus EnvisionTech is the same exact way. It's a little bit bigger printer. That's the resin tray. You pour the resin in there, select what you're printing. And then you see layer thickness is 100 micron. So higher the microns, faster it's going to print. So it will print all these models at one shot. Go back to. Okay, so let's talk about how you can get started, right? Export the STL model to a 3D printing software. So each printer is going to have its own software that it will allow it to work. So it depends on what printer you get. Sprinter has its own software. Formlab has its own software. There are some open source softwares that cheaper printers will use, like Frozen 3D. It will use open source software. Select which is going to be on the bottom. So if you print a model, you need to make sure that the printing starts from the bottom and not from the teeth, because every time it starts printing, the first 3-4 layers are deformed, and then the accuracy starts. So you need to start printing away from the detail-oriented base. And then, again, depends on what you want to print, model or crown or bridge, your resolution is going to change. So this is how you nest onto a software. This is a hybrid for a patient all-4 as a temporary, and it's going to stop printing from the teeth up, but it's erased from the platform. So when it starts printing, the first couple of layers are going to deform, and then it's going to print very, very accurate. That's why it's erased above the platform. You do not directly print on the platform. Once you print, you got to wash it with the isopropyl alcohol. There's some resins are water washable. You just wash it with the water and you dry it. It removes the uncured excess resin. Then you would cure it. It creates basically your resins are composite, right? It's the same thing as a composite, a flowable composite. So it needs to be cured. And you use curing boxes for the polymerization and validation. It makes the resin biocompatible because everything is cured and it removes all the toxins. So this is a setup on our Form Labs. You select the resin, what version, and then you can select the layer thickness. So if you go 140, it's going to print faster. If you go 25, it's going to print slower, but it's going to be very, very detailed and very accurate. This is an open source software, which is called G2Box. And basic functionality is the same. Whether you use any software, you're going to have the platform, you're going to have the supports that's going to raise the model above the platform. And depends on what you're printing, you change the support settings. Bigger the model, you need more supports, more interconnected, so that the print doesn't break off while it's printing. So how do I use this in this office? So we scan every patient that comes into the office, and then it depends on what they need. If they need a occlusal guard or a temporary crown, we design on a CAD software, which is exocad, or 3Shape, or we can use any open source. Blue Sky Plan is another open source that's free to use, but you design that, then you send it to the printer, then you post process. So what can you print? Occlusal guard, dentures, temporary teeth, occlusal guards again, some different occlusal guard, which is firm and soft occlusal guards. These are the models for retainer making. For your retainers, now before you could not print the retainers directly. Now we could print aligners directly on without making a model. So this is a little older slide, but it'll cost you about probably $2 to make a model and print it. So same day, if a patient comes into the chair and they are missing a retainer, or they want a retainer, or they want to start the aligner therapy, what we do is we scan them. We'll print it. It'll take about 20 minutes, and before they go, we will make them a retainer to go home with. So patients start the treatment the same day. They do not go home and think about it and change their minds. Surgical guides, I'm pretty sure surgical guides is pretty universal now, but we use 3D printed surgical guides for all our surgeries. It makes the things work really fast, better surgeries, better outcomes, and very accurate. It takes about 20 minutes to print a surgical guide from design, and another 10 minutes to cure. But it's really affordable. It costs about $20 for a surgical guide to be made at the office. Crown and bridge. And now US allows a temporary printed crown to be considered a permanent crown. So you can bill the patient. It's pretty strong. It wears like an enamel does. Jury's out there. We haven't had a long-term data on it yet, but these are definitely classified as a long-term temporary. So if you're rebuilding an arch, or a patient can't afford something definitive or expensive like zirconia, this is a great material. It costs you about 50 cents to make a crown. So data works the same way. You're going to capture the data, you do the crown prep, you design in the office, or you send it out to design. Nowadays, artificial intelligence is used, so it gives you crown back design in 2 minutes. It sends automatically to the printer. You print it, you cure it, polish it, and you put in the patient mouth. It takes about 25 minutes to do that. Cost, again, I said, 50 cents if you design it yourself. If you design it outside, maybe $2 for design and $3 for design. Clear aligners, newer material. Now you can print clear aligners directly. So you scan the patient, you design the teeth movement, and you print the aligners directly on the platform. First day, first tray, that's a really good revenue source, especially people are busy, they don't want to come back, delay the treatment, postpone the treatment, and they will not, have a buyer's remorse. When they go with the first tray in the mouth the same day, they are less likely to change their minds later on. So now this is an older workflow, but it's still valid for most of the people. You would scan, you create the design, you would print the models, and then you would make a vacuform, because now with the new technology you can print. So this is going to change again, but it's like a whole case can be done by $50 or something like that, versus Invisalign. Here it's in the US is about $2,000 per case. I am not sure how much is in India, but this is really affordable for patients. Dentures. So we always give patients 2 dentures. So if the patient comes in with a broken denture, we'll quickly scan it and repair it and print it. It takes about 30 minutes, 40 minutes to print. You can either print in white and paint the pink, or you can print in 2 different colors. This is a denture-based resin, and this is a teeth resin, and then you would just bond them together, and it's really solid. The cost of doing a denture is probably about $10, $15, and again, it takes about an hour to do everything. $10 denture, there you go. Workflow remains the same. Capture data, plan, send it to the printer, post-cure, and you can give it to the patient. Now, I consider this dentures as temporary dentures, because after a while it does lose the shine, it loses the, it's not as strong as a heat process denture acrylics. So these are great to start off with, or as a trial dentures for most people before you would proceed with the lab made. All on fours. Patient comes in. Now we can scan this extraorally with the camera, and it will give you a verified cast that you can make without pouring a cast. You can make directly the all-on-4 that will screw on top of these implants. Again, without having to take any impression or verification jig. Again, it takes about $20 to make one all-on-4. Occlusal guards. Again, patient comes in, have a TMJ issues or orofacial pain, and you want to give them something right away. Takes about 5 minutes to design, another 20 minutes to print, 25 minutes to print. Patient goes home, and great for trial occlusal guards. We give patients 2 every time, so they have always 1 spare. It costs you another $2 to print another one. There's different materials. There's the flex that it will give a little bit like a soft night guard. There's also firm material, which is really, really hard night guard. We typically advise firm, not soft ones, but it's really great material. The breakage is very, very minimal with this night guards. So process remains the same. Capture the data, design, you can send for AI designing, bring it back to the 3D printer, print, wash, cure. You can do digital occlusal rims. So you would screw this on the patient, and then you would adjust the occlusion on this, and then you would recapture, rescan this, and now you have patients' vertical dimensions of occlusion, and it's very, very accurate rather than having a wax rim that moves around. This is fixed and gives you much better results for the long term. You can have models with built-in articulators. that will replicate the jaw movements. You don't need a special articulator anymore. That takes about an hour to print for both arches. And now you have built-in jaw relation articulator. So that's the 3D printed material. You can see it can look really, really beautiful and gorgeous. This will last quite a while as long as the patient is instructed not to eat hard foods like nuts and stuff like that. But the new materials are really strong. They're approaching Emax values nowadays. Working trials, you can print temporary veneers, bond them together. This is how the patient came in with a smile, and you can see within an hour, we were able to give him something that is, we can try it out and see if any modifications are needed. That's an all-in-4, printed all-in-4s for this patient. Patient brings in with a photo that she used to look like that. This is how she looks like now. Do the surgery, you print it, and this is the same day and after 3 hours of surgery and temporary printed. So possibilities are endless. Less expensive, less time, less. You can see more patients in the same time. So that's about it. Every day this realm is changing, and I feel like it's gonna be the future. Future's already here. So thank you guys for your attention. Any questions?
Thank you so much, sir, for wonderfully taking us through the present and also the glimpse of the future. It was amazing to hear to you.
Awesome. I'm
Yeah.
glad you enjoyed it.
So shall we take up some questions?
Sure.
Yeah. So firstly, do we need any special resin when we talk about 3D printing denture bases?
So denture bases need biocompatible resin. So there's various resins in the market that are approved for denture bases. But anything that you can use any teeth resin for as a denture base.
Okay. And so how do we bond the denture base and the 3D printed teeth that have been separately printed?
So you use the same resin. Basically, you take a little bit of pink resin, you put it inside. Let me see if I can go back. So you would put resin into this holes where the teeth are gonna go. So use the same pink resin, just dab coat inside, seat the teeth inside, and then you would cure it just like you cure your composite, and it will be bonded.
Right.
Understood. You don't need any special bonding agent or anything like that. It's just the same resin.
Okay, sir. Thank you so much. So one more question. We talked about two different slicing softwares, open and closed. What is the difference between them?
So open source, it works with lots of printers. So this is called Chitu Box. You can download it. It's free to use. You can do whatever you want. It works with majority of the cheaper printers that you can buy on Amazon. So if you're gonna buy a printer for the models, you can buy a resin, which is like $60, and you can print your models with this software. Printer is $300, probably less than $300 now. Resin is probably another $50, $60, and software is free. But each printer needs to have a software that will send a file to the printer in a native command. So Formlabs, more expensive printer is going to be, their software will only work with their software, their printers. So you cannot use a Formlabs software with the Sprint Tray. You cannot use Sprint Tray software with the Formlabs. The cheaper printers will work with any open source.
Okay, sir, understood. And sir, we talked about the pricing related to what the dentist has to pay for. How about the patients? Does it make a huge difference when we talk about 3D printing procedures?
Absolutely. So if you were to send, let's say, all on four, let me show you all on four. So if you were to send this to the lab to make this all on four as a milled PMMA, they would charge you anywhere between $800 to $1,200. In your practice, it's $20. And then you can make multiple. So you can have print 2 or 3. If patient breaks, there's always another one to swap out, and it's cheaper for the patient. So instead of charging patient, let's say, $3,000-$4,000 to cover the cost for the lab and time, you print this, and now you can tell the patient, hey, you know what? You pay me $1,000, and we're still making money. It's still more profitable for us to do this rather than the lab.
Okay. So one last question, sir. So when we talk about 3D printing dentures, how do we adjust, balanced occlusion with 3D printing?
Just like you were adjust your composites. You use the same burrs.
So that has to be adjusted separately by the dentist after the dentures have been 3D printed.
Yes, you can. So you can either do the whole regular workflow, like you have a wax rims, you do the wax rim, you try and put the teeth and stuff like that, or you can print the denture, put it in the mouth, adjust it, and then you can rescan, and you can print an accurate new denture base will remain the same. It's just the teeth that's going to change. So the denture base you print again, and just to print the new set of teeth, and you put it on again.
Okay. Thank you so much, sir, for being so patient with our questions. We would eagerly look forward to meeting you in Kochi. And as a concluding note, sir, what's your message to our participants who are interested in learning from you in Kochi this year?
Kochi Expo seminars are probably one of the best in the world right now. There's so much info in a short amount of time that you cannot miss it. It's absolutely must do.
Thank you so much, sir.
Absolutely,
Have a good day ahead, and thank you so much for sparing your valuable time to be with us. It was wonderful listening to you.
Thank you for the opportunity.
Thank you, sir. The pleasure was ours.
Bye-bye. Good evening.
Bye. Okay, thank you.